This is a features and overview of an AiM MXS 1.2 Strada. This is a evolution of the original MXS Strada, which is a 5-inch color display. It's configurable to show lap times and all the info coming from an engine control unit, and as well as analog digital inputs. And you can have predefined math channels, and optionally you can connect via CAN the GPS 08 module, which will give you GPS-based lap times. So this device comes with an OBD2 communication port on the 14-pin standard harness, or a flying lead CAN connection for the ECU. You also have the opportunity to add the auxiliary harness, which adds 8 analog inputs, as well as some more digital inputs and outputs. So the device here is booted up. Currently we have it connected to a LCU1 lambda module, and it's showing just a free air lambda reading right now currently. So you can see 23.3 here. We're going to use RayStudio 3 to simulate some of the analog inputs as well as the ECU signals, so that we can look at some of the functionality of the device, as well as conditional alarms that can be set up. This particular unit is the MXS 1.2 with icons, so we'll force it here to blink through all of the available LED colors, and you can see the icons on the left and right wings of the device here. So initially we're going to just simply simulate what happens when you turn, let's say, the headlights on via an analog input. So you can see here that blue light becomes illuminated, and obviously you can change the color of the illumination there. So that blue icon simulating the headlights. Now for the high beams, the green one, and then let's say the hazards, you have that there. So we'll step through the rest of the warning lights here for the icons, as well as the warning lights on the page. So just simply we're going to simulate, let's say, an RPM here. We'll say 3000 RPM, and you can see the bar graph here indicating the RPM that we're simulating in RayStudio 3. We'll simulate a throttle position, which will show up here as TPS, let's say of 80%. So the nice thing here, now that we've set the throttle position above a certain amount, it knows that the engine is almost or under sustained load or almost wide open throttle. So the fact that the LCU1 is registering such a lean condition is triggering this alarm here. So it's showing a red value for the free air, which is 23.3 to 1 AFR. So if I just take a simple barbecue lighter and I inject some butane towards the sensor, you'll see it will get richer. So we can go towards stoichiometric, and then when we hover around 12.5, you can see obviously the warning starts to go away around 12, and if we go quite rich under load here, if I inject some more butane, the warning will go away. So obviously I removed the butane, and it's showing lean. Adding more butane here. You can see it going richer. Add some more butane from this. Okay. So we can go through and step through the rest of the alarms here. So let's say the coolant temperature, if we have 60 degrees Fahrenheit of coolant temperature, that value will show up here and it will be shown as blue, as well as the value over here on the icon. And then we can, just to signify that the engine is, the coolant temperature is still cold. So let's say if we step to 215, which would be above a certain alarm, the first stage of warning, it'll indicate yellow. And then if we go to, let's say 235, it will show a coolant temp warning. So we'll go back to 215. Similarly, we can do the same thing for boost pressure or map. So we'll, let's say 23 PSI map pressure, that'll show the live reading there. And if we exceed the first stage of alarm, let's say to 25, it's going to show that as yellow. And if we go past and we go to 27, it'll show an overboost warning. So this particular device has been configured for communication via CAN with Haltech range of ECUs on a 2JZ Toyota engine. So that's the conditional alarm being set up here. What's nice, the fact that it's conditional, is that if we remove the engine RPM, some of these alarms will go away, and then the throttle position obviously will go away. Similar, or I guess this would be important for things like oil pressure. So if we, let's say, have an oil pressure here of 40 psi, that's okay with the engine running. However, if we have an oil pressure of 20 psi, it will show a low oil pressure warning indicated by this red flashing icon here. So because the RPM is above a certain amount, it needs a certain amount of oil pressure that the user can configure. Obviously, this will prevent some false alarms from occurring before the motor is started at the 0 RPM when there is no meaningful oil pressure. So we'll go back and let's change this to, say, 28 psi, and you can see that that's just a warning now, not a danger alarm for the oil pressure, and it's still indicating overboost. So we will lower that here to, let's say, 25 psi. Okay, and for fuel level, which is the final icon, we can simulate, let's say, 14 liters of remaining fuel, which is indicated here, and it's showing a first stage of warning as yellow, as well as the icon up here. And then as we deplete the fuel in the tank, we can say 9 liters, it's going to show fuel level low. So this is a stage 2 warning with a red icon being illuminated. So we'll go back to 14 here, and we'll go once again to add some butane to the LCU1. So you can see it getting richer there, and we're hovering around the alarm. And now we're back up to free air. So we can also just simulate the LCU1 number. So let's say we force it to be 12.5 AFR. You can see there that the warning turns yellow, and then if it's rich, so we can change this value to be, let's say, 11, which would be allowable under full load, the warning goes away. However, if we go back to the warning state, let's say 12.5 to 1 AFR, and we remove the throttle position, obviously under partial load, let's say we make the throttle position 20. Under partial load, closer to stoichiometric, leaner fuel ratios are allowable, so the alarm will go away. So you can see here that that yellow illumination went away. So you can configure a few different screens to be in Race Studio 3. So we click View, we can go to the second screen, which is displaying the icon page here of the currently selected alarms. So it's showing now a more traditional analog tachometer. So the RPM there, and then the coolant temperature, similarly, it's at the stage 1 warning. The boost pressure, the manifold pressure, stage 1 warning, and the oil pressure is not in the warning state right now. or it's in the first stage of warning state. So you can see at the bottom a whole bunch of icons that have been illuminated for, let's say, the battery voltage is below what the alternator would charge at, just because we're connected to a 12-volt power source here. We have the low beam headlights as well as the high beam headlights turned on as indicated here. We have the flashers on. We're in a overboost state, so you can see the turbo icon there displayed, as well as we have stage 1 low fuel warning as well. So the final page that's been configured in Race Studio 3 is just a kind of an ECU check summary page. So if we simulate a gear position, we can show that in the middle of the page. If I can find the gear position here in Race Studio 3. So we'll force a gear position of, let's say, 6. So you can see there, and it will calculate it based on your GPS speed and RPM if you input the gear ratios or you go through the learning procedure, or it can receive this data from the ECU stream itself. So we have a whole bunch of different parameters available here for the Haltech ECU. This is just a subset of the total parameters, but things like engine RPM, coolant temperature, throttle position, fuel pressure, manifold pressure, oil pressure, ignition timing, the wideband from the Haltech stream. This is the battery voltage. This is the LCU1 that we're simulating to be 12.5. The knock correction. This is any engine limit imposed by the ECU alarms. The lap number, any check engine lights, the oil temperature, target boost pressure, intake air temperature, and the fuel level in liters. The final thing that I'd like to go through on this particular device, if we click menu, it allows us to configure, if we remove the engine RPM, it will trigger the session as being done here in a second, and we will be able to click menu and review it. So we can configure the date and time. We can configure the backlight settings here, so you can see that it's manually set. We can change it to automatic backlight. We'll leave it on manual for the purposes of the video. And we can go to the next one. This particular, the new 1.2 versions of the Strada dashes have video input. So you can use a mirror camera or a rearward facing camera here. So the device can have effectively a backup camera, or in racing situations, a backup camera for a street car in racing situations, you could have a blind spot camera or something to that effect. As well as some counters here, so you can see some trip meters for hours and mileage. This is your GPS and tracks. We currently do not have a GPS 08 module connected to this Strada dash. And then system info, so to look at things like the boot version, the firmware version, and the serial number. So we'll go back to the home page here. We'll stop forcing all of the values, and you'll be able to see that everything here will go away. Our battery voltage is quite low, so we're nearing the end of the video. If I click memory and then today's date, we can look at one of the sessions that was logged, and we can look at the peak RPM and mileage for that particular session. If we go back to the test, we can select another one, let's say yesterday here. So we'll do this one here. Actually, we'll select the latest one here, and 3000 RPM, and this was 9 minutes and 59 seconds. So that was a brief summary and overview of the AiM MXS 1.2 Strada. This is a great dash logger or a dash display, and as well as there will be a logger that's coming out in the near future that can connect to this device here. It's a great dash display for street cars, as well as the icon version does allow some mimicking of what an OEM dash would look like. That is in conclusion of this video.